Buenos dias, Buenos Aires, that was my Spanish. Welcome to my talk, good morning. So it's about tracing node and it's the open source edition. Just real quick, I would like to know who is already now somehow tracing, monitoring their Node.js applications. Awesome, so I have to show you something, because my goal would be after this talk that on Monday you start monitoring your application and you know and have the tool at hand and you can use solely open source tools for that. So I'm Daniel Kahn, I'm developer since 1999 and doing Node since 2012. I'm lead technology strategist, but I guess they said it already. I'm from Austria. That's this little patch here in Europe. And we are known for Mozart, Red Bull, and Californian governors. This is like what we look like on a regular Sunday. So. But seriously, if you ever end up in Europe, just drop by. Austria is small, so you can just travel through it and see nice places like that one. For this talk, I created a new application, something great to solve one of those big questions of mankind once and for all. And I would invite you now to really also look at that. So I need you for that really now. So take out your phones. You should not do that during a conference. Now you can do it. And go to vote.demo.can.io. And I figured out that was the first time that I even tried it. If you point your camera at it, it really opens the URL. Pretty cool. And so if you don't have a phone on you, that's my app. So it solves this problem, tabs versus spaces. And I want you now to vote for that. And so while I'm talking, keep voting for that. And the fun thing is you can do it like multiple times. So vote what you prefer. I'm actually using you as minions now for my load testing, right? So I just have this first launch and I now want to see if this really works, if the application works. Okay, well, you're playing with that. Do you have some time to talk really quickly about monitoring? So I'm working for Dynatrace, that's an APM vendor. And now I'm standing here and I want to show you how to use solely open source tools to monitor your application. So how does this even fit together? The thing is, the metrics collection and also the display of metrics for mid-size or smaller applications, that's a solved problem. So also, of course, we show you metrics like that, and that's fine. But the real challenge of large-scale performance monitoring, and that's what commercial vendors do, is really making sense of a lot of large application and to understand your whole environment. And to get started with that, open source is a good thing, and even the open source tools I'm showing you now and today, you can use them and you can ingest the data into many commercial tools. So that's a really good way to get started, and you can get a long way. And if you then get that big and your problems look like that, so you have to discover something like that, and this is your team that writes just the logic for the monitoring of your application, and that's your network operations center, then we should most probably talk again, because then you most probably need something bigger. So that is my app. I have to say, I have teenage kids, so I have a big emoji game going on now here for this talk. And it's a Node.js app. And now you're operating to it. So that's the app you're playing with, hopefully still. I don't see anyone typing, so yeah, whatever. And for this app, when you're measuring it, you want to get metrics out of that. For instance, response time, event loop metrics, some garbage collection information, heap usage and CPU usage. And all of those metrics, and I'm losing my mic here. Let me fix myself real quick. And all of those metrics would be worth a talk on its own. But what I'm showing you now is how to best collect them for your application, and I will show you then an example on how those metrics behave in production environments. And to get this working, I created a metrics collection pipeline. And this took me for this application maybe 1 hour or 2 hours to get that actually working, to get metrics out of my application. It's not a production setup yet, but within 1 day you should be done with getting really all data that you need. So what I did is I need some metrics agent. So I need something in my Node.js process that collects the metrics out from this process. And for that, there is already now a standard that more or less that's statsd, so that's a project from Etsy, and it's a server, but also defines some kind of data format to send metrics off of a process. And for that, there are modules. So I used AppMetrics statsd. AppMetrics is another open source project. It's polyglot and it has a lot of instrumentations for different languages. And it will start simply to collect data out of your Node.js process. And then I'm also using Express statsd because I also want to know a little bit about my Express routes. So I now have all this data in process. What I want to do next is I want to get this data very quickly out of process, of course. And for that, I'm using an UDP channel that sends this data to a metrics collector. So that's some daemon that is running on your server. And in this case, I took Telegraph, and it understands this statsd format. It's also an open source project by InfluxDB. Now we have this data, we have to do something with this data. We want to aggregate it and transform it and send it to a database that is dedicated for storing this kind of information, and for that I used InfluxDB. So this, we have now all data in a database. Now of course we also want to see this data. And for this whole dashboarding, I was using Grafana. It has a data source that understands InfluxDB, and then you basically have all you need, and your Node.js process is already collecting data. To get this into your Express application, for instance, very simply, so as in the moment you start this AppMetrics statsd or like instance stat, it will start collecting metrics, because getting metrics out of Node.js, like process metrics, is pretty easy. And I also get this Express statsd middleware here, and I simply plug it into my Express application as middleware. So I'm now trying, you can follow along if you want, it's on /metrics, because I want to see if you were actually with me now. So I go into my Grafana dashboard here. Yeah, not so bad. So we see here already that you were doing something, and yeah, here we see the number of requests. So yeah, not so bad. So we got a round of 1,000 requests now while you were doing this test. So I'm pretty excited and also grateful that you did. And here we also see the memory usage. And here you pretty see that I built in a memory leak, because the memory is constantly growing. This is something that should not happen. And it's also not falling a lot. And I show you the worst case. So I will leave that running all day, so you can play around with it later. You can log in with user test and password test and really look into what I did the last few days when I was preparing for this talk and the different scenarios I did. Here I unfortunately used a little bit of a bad coloring, so I hope you see anything here, because I tried to get a scenario where an application really behaves badly and wanted to show on monitoring with the metrics what's really going on. So first of all, you have here the memory usage. And as you see here, we have this sawtooth pattern here. This sawtooth pattern tells us that actually I'm using PM2 on the server side as process manager. So the memory builds up, and at some point it just cannot go further and stops with an out of memory, and then it starts again. So this is a typically fast developing memory leak. What you would see in more realistic production environment is a slow build-up, but in the end you end up at something like that. But I couldn't wait for days to build something like that. So okay, memory usage bad. Then you see the GC duration, if you see it, it's here a pattern like that the GC duration goes up constantly and then also falls when the process starts again. So what this means is, and Of course, the garbage collector of Node.js, the more memory Node.js consumed, it tries harder and harder to get this memory freed somehow. So it runs and runs and runs and runs constantly. The problem, and why the GC duration is an important metric, is that while the garbage collector, and there are two in Node.js, one faster one and a slower one, so the fast one runs more frequently and the slower one just sometimes. So while this garbage collection is running, the process will halt. And it cannot do anything, but your system is still busy. As you see it here on the CPU usage, your system is still busy on the CPU side because garbage collection costs CPU. So you can exhaust a system pretty much and get a very bad performance just from that. And you see it here already on the response time, also very hard to see that the response time goes up, 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 up. And this is mostly connected to the garbage collection that is running. And of course, the number of requests logically goes down. And to also better understand what's really going on here, I just put the bar in here because you see, interestingly, that when the CPU usage is very low, we have the highest response time. So that's a big indicator that what your application is doing is not, or it's busy with doing something else and not processing actually user interactions. And as you see here, yeah, it's the same. So the kind of bottom and the tops kind of intersect here. So now, awesome, we see that my application is very successful already. So I decided to use microservices, and I like pictures for microservices that look like that. Why am I using microservices? Because it's cool and because I can. I want to build something like that. So I want to have a front end, then I want to have a service gateway, and then I have a service green or service blue that connects then to a database. So because now, until now, I stored all your votes you did, I stored them in memory, which is not maybe such a good idea. So I put a database on top of it, and this blue-green scenario here is very typical when you, in microservice environments, when you want to use like roll out different versions of one microservice. So you do this blue-green deployment. And it's again this application, if you want to look at that, it's not that important, but it's now on /bg, so vote_demo_can.io/bg, and it looks the same, identically. You can also go there if you click on this little tiger here. And what you will see when you try it is that sometimes the metrics here, so that the voting here shows this skull, because something on the back end goes wrong. The problem that we are now having is, what did go wrong? We have a service gateway, we have services there. So how can we solve that? How can we find out what's really going on down the line from our front end down? And for that, we have to talk a little bit about microservices at all. So I have my pretty application here again, and now I'm having new applications that they don't have to be Node.js, and I have a little lion and a panda and some thing. Then I have a legacy application down there. Then I have a not so mature application, so it's not so awesome. Then a Chimpy, one unicorn, we need unicorns, and then something that is a little bit not so good. And of course, all these things are totally interconnected. You're using Kubernetes, you're using some service deployment, and this is now running awesome. And the problem is now you have this incoming request, and this part, this service fails now. And consequently, of course, everything down the line here fails, and of course, the whole request will fail as well. The question is now, how can we look into that? So how can we turn on the light? How can we understand the whole transaction and find the root cause of our problem? For that, I stretched now this transaction a little bit apart. And let's say we call such a transaction a trace. And within these transactions, or within these tiers, within these applications, there are timed actions that are going on. And let's say we call those a span. So in every tier, there's something going on, and there can be multiple spans, like a waterfall chart, within each tier of the application, as you see here. And here we have the failing one. So that's great already. So we are doing something. We time operations there, we measure operations in there. What we also need then is we need a way to pass down the information in which trace we are right now down these tiers. So we need some way to propagate context, and we call that trace context. And you see that we have to propagate context over the wire, so on the network, but also within this application. And such a trace context could be a trace ID, a parent ID, and a span ID. And as you might see, this forms basically a tree. And of course, we can also create some metadata, collect some metadata from our process, like HTTP status codes, etc. So that was not my idea. The whole terminology I was using was not my idea. It goes back to the Dapper paper from 2010 by Google. This describes how Google did monitoring in large scales 2010. And everything open source that was going on from then is basically based on this Dapper paper. So it's a good idea to look into it and read it at some point. So let's talk about context propagation, because that's a real challenge in Node. So in a perfect world, I would have here my HTTP request, and last year I talked about the event loop here. And as you might know, Node.js runs in one single thread, but let's say it's PHP. So I can store my current trace ID and span ID and all of that in a global context, because this thread will just deal with my request at this time. Then we have some HTTP GET call, some callback, and then we have this outbound call, and there we can put our context in some HTTP header, and the next process can easily pick that up, and everything is just fine. Unfortunately, that is not how it works in Node.js, because in Node.js, if we play this scenario through, we have the HTTP request that, and we store that, let's do that in a global context, and then we have a HTTP GET call, which then runs, after all, on the event loop, and while the event loop is busy doing your call, Node.js can again take a new request. So we have a new global context. And now this callback is running. And while the next Mongoose find here is running, we have a new request coming in, and we have a new global context. So globals are not a way to solve this problem for Node.js. What you actually need is, you need a way to, for each transaction or each request you're having, and Node.js, if you think about it, is basically always, if you look at Express, it's a cascade of callbacks. So it's an incoming HTTP request, and then things are happening. It's callback after callbacks. And you have to get this context in each callback. So, and that's a pretty complex problem to solve, so you have to do something like that. In our code base, we created something like a stack for that, so you have pop, push, whatever, what you have on a stack. And then we, here, as you see in green, for instance, if we want to patch set timeout, we replace the real set timeout with set timeout substitute function, and this substitute function will wrap now the callback of set timeout and will put the current context into the scope. And that's easy, right? The problem is, and that would be really easy, if you want to do monitoring, you have to do this in Node.js for each and every library and each and every function that somehow passes the event loop. This means if you have MongoDB for every find all, for everything that's going on in Node.js, you have to write a dedicated instrumentation to get this properly working. So that's a pretty challenging task, and of course, and luckily, there are tools for that solve parts of this problem. So we talked about this whole Dapper thing and all those principles behind that, and you would think that this problem is also somehow solved, and there is a common standard and one common tool to solve that. And the good and the bad news is there are several tools and standards that can be used to do tracing in your application. First of all, there is Open Tracing. It's a CNCF project, and the interesting thing about it, it defines just an API. So it just tells you how your tracing code should behave. So you have to write your tracing code basically on your own. What's cool about it is that many Kubernetes projects, for instance, are having an interface where you can then throw your own tracing logic into it and then do what with the tracing that this thing gives you what you want. It has no UI or backend, it's just a standard. And it looks pretty complex. So this is just when you want to wrap an HTTP call. So there is a lot you have to do to get this working if you start from scratch. Then there is OpenCensus. It's open source, it's driven by Google, so it goes back very much to the Dapper paper. It provides you with a full instrumentation, so it has code that instruments your code like your Node.js application for real, at least out of the box, the HTTP calls, the inbound and the outbound, and it provides exporters to a variety of backends. And this is already, as you see, it's quite easy to use. You can start a span, you can create child span, so that is pretty straightforward. So you can instrument with that, you can instrument your code. And then we have Jaeger, which is a little bit different because it's mostly a UI that can ingest all this data that comes, for instance, from OpenCensus, OpenTracing. And there is Zipkin. And the example I'm showing you is from Zipkin because it's the oldest one. It most probably is not the coolest one, but the format it uses to communicate traces is more or less the standard. It's based out of Twitter, and it also provides a full instrumentation. It also provides you with ready with an UI. And that is, from my perspective, like for a talk, the easiest way to show something. So what I want to achieve is, I have this front end, I have the service gateway, I have service green and service blue, and I want to at least know where where the requests are now actually failing, right? So I instrumented that, and I also want to, of course, see some kind of waterfall to see what's actually going on there. And to make this work, I just created that's not even a model, it's just some code that then will create this tracer for OpenZipkin, gives you a middleware for Express, and also wraps the request. So it's just some code, and I will have a gist then to look at that you can use later. So what I'm doing now is I have this agent, this Zipkin running in my Node application, and I have traces and spans that now, again, have to go out of process, and I send them to Zipkin. In this case, Zipkin is just a Docker container with an in-memory database, so that was like a 5-minute setup to get this working. And this data is now ingested, it's somehow processed, and then it's stored. And we get also a nice web UI that shows us the traces that run through our system. So I have this done, and you can also later look at that. I will try that now. I have it open right here. So these are the traces that run through my system now. Let's look at the real time. Let's see if anyone did anything meanwhile. Yeah, there are a few. So, and I can drill into that, and I can see this, that here's Express frontend, the service gateway, and I have this green service. Let's see if I can find a failed one really quick. I don't know what's going on. So that one, you did not do a lot on this test, but luckily I have something ready here. So what this will give you is, and as I showed you before in this other tool, is it will really show you the whole, how your systems really connect together, and it also shows you where things are failing. And here we see that service blue in this case is failing. And this is a lot of information, like good information to have about what's really going on and why things are going wrong. So I have this here again. So if you drill into that, you see that, and then if you go further, you see also this HTTP status code coming from your service so that you have an HTTP 500 here. Okay, so how you get Zipkin into your application, that's on this gist, so you can use gist github.com, Daniel Kahn, and there you will see the instrumentation I've built for that. Also, if you want to play around a little bit with this whole monitoring and with the metrics I collected, you can look at my Grafana dashboard during the conference, and also look at my Zipkin dashboard. And that's it from me. Thank you.